Hi everybody, my name is Patrick Spicer. I'm giving a tech talk today on recommendation engines. You've seen these before, most likely. Recommendation engines are pretty much where you like something, you look at something, and then the website will present to you, you'll probably also like this other thing. And then you go look at that and you give them money. So like I just said, they're a subclass of information filtering systems. So mostly what I'm going to talk about, you'll see me keep using the words filtering. That's all they're doing is filtering data down. And it just tries to predict or rate an item or what it thinks your expectation of that item will be. There are two typical approaches to these. There's the collaborative filtering method and the content-based filtering method. I'm going to go over each of those, touch on a little bit of the other ones. But like most things, they have their strengths and weaknesses, and these things are by no means perfect. They use search algorithms a lot, and they kind of just tweak them to sort of work towards products and people and things like that. So it just says, ironically enough, these are all often used in these recommendation engines because people were trying to get away from search algorithms, but they just kind of came right back to them. The collaborative filtering method, you could see they try to analyze large amounts of user data through behaviors, activities, preferences. This method is really more about you like this because somebody else that also likes similar things as you likes it. So with this one, it's mostly like user-based. The cool thing about this one, though, is it doesn't rely on machine learning or anything really like that. It can do complex things like movies because it's using people to do most of the filtering. And we're able to say, I like this. You can go from one thing to another thing really quickly. And you can start to get overlapping patterns. That's what most of this stuff comes down to. The one thing to keep in mind is it does assume that something you like now, you'll like in the future. One of the other methods, it's all algorithm based, so you can do like decay, time decay, things like that. But this method pretty much assumes that you like it now, you're going to like it later. There are two methods of data. So data collection for these, there's explicit and implicit. Explicit is you're doing something. So you're taking an action. They're asking you to rate something. You are physically doing something, and you are giving the system inputs. Implicit is, I think of it as a little bit more passive. So you're on the site, you're looking at a product. You recently purchased a product. It's using that other data. A site bought some of your data from somebody else. They can use that. So they all use these two types of data collection. It's just important to know that that's how they're getting it. You've seen that with this is like with Netflix. You watched the A-Team, so now they're like, you're gonna like Knight Rider, something like that. So there are two methods for this main bucket of filtering. There's memory-based and model-based. I sort of touched on this earlier, but memory-based is just you like these things in the past. It compares you pretty much directly to somebody else or something else that has liked the same things. And it just kind of shows you the gaps there where there are things that that group of people liked that it can now show you. The cool thing about this is when you tell somebody the results, they're like, oh yeah, makes sense. So you can get these things up and running really quickly. Like we could probably go in the other room and knock it out in a little while just because it's just overlapping data sets. So just do some array and hash filtering and things like that, and you could probably do it. So content independence of items. So these things can be in different kind of verticals. It doesn't really matter. And as long as you have sort of rated similarly items and things like that, you can add more items as long as they're close to what verticals are already there. You can kind of get those things in there pretty easily. There are two disadvantages. The main one is if you don't have data, if you don't have users in your system liking things or watching things, like that type of critical mass kind of stuff, its ratings get less and less accurate. So you need people actively rating things, basically. And similar to how I said, as long as the items are sort of there in an existing vertical with the same keywords and things like that, you can add items quickly, but as your item list grows, when you do add items, it has to re-rank every existing item that's there for the new inputs, or it's never going to surface that item because nobody likes it, nobody else likes it, no one's ever going to see it. The other way that you can do this collaborative filtering is model-based, and you want to think of this as a little bit more algorithm heavy. So slightly more focused on being able to come up with some type of technology to look at what's there and present that to people. But again, it's still user-centric based, so it's still looking at what some users are liking that are like what you like, but you haven't seen yet, kind of thing. You can look up the collaborative filtering algorithms that they usually use, Bayesian networks, clustering models, things like that. I did start going into it. It gets confusing pretty quick. The Bayes stuff is not too bad, but the other things. You can see that there's a lot of thought put into these, so you need to be knowledgeable of that. Some advantages here. This one, you don't need as many people in there liking things, because it's using, you're telling it to find these things for me, and that's why you made your algorithm, basically. Let's see. Oh, one other thing is these things will reduce data down to get it back to you based on your criteria, and that's one thing that you can lose since it's more algorithm based and not so much based on people. What's going to happen is the computer's just going to toss away things that it doesn't think you need, but maybe it would be cool to see. So just in general, collaborative filtering has got its disadvantages. The cold start is you need data to start. Like you need to, it starts at zero, basically. You got to train it. You got to get people in there liking things, or what a lot of companies do is they actually pay people to do this just all day long. So if you need a job. Scalability, this is really important. The way it ranks things in these, as you trend towards using more algorithmic type things, the way that these are set up in general, it gets really heavy computationally. And again, sparsity, it kind of fits in with the cold start thing, but even though, even the most active users in your system, they're not going to have seen very much of your database at all. So you picture Amazon, I don't know how many things it's got in there, but even if they pay you 8 hours a day to rank everything, I mean, how much could you actually get? So the second method is a content-based approach. So if you remember the first method, I was user-centric. This is starting to shift towards being more based around the items. And Pandora is a good example of this. Because the way this works, you pretty much give it a training thing. You're like, here you go. I like No Woman, No Cry by Bob Marley. And then it then takes that criteria that you give it, and it serves up a song that you might like that matches things based around that item's attributes. So you're applying keywords and things like that. What's cool about this is then you can also give it upvotes, downvotes. You can also then dictate to the system, and it uses that algorithmic approach to learn, basically. Here's one of the functions that is commonly used. This was actually one of the more simple ones, that's why I tossed it up there. It's called a term frequency inverse document frequency. So the example that I can give is you have a phrase, the brown cow. It looks at all the documents or items that you give it, and it searches for those words. And the term frequency is matched against the actual word frequency per document. So that was designed because the word the was getting super high rankings and things like that, but the word the isn't the important word. Brown and cow are the important words. All right, so with this method, you're going to have, there's two main things. Like the user makes a profile of preferences, and then it keeps track of a history of interactions you've made with it or others have made with it. This is why I use the example of Pandora, because I give it the first song, and then I interact with the system, and then it keeps learning. So it goes off of just me. So similar in our Pandora example here, direct feedback, like or dislike button, it's gonna train itself a little bit. You can do really simple approaches. That way, if you know all of the types of inputs that you have, like items you have in your system, you can give them specific keywords and things like that. But then you can get back into these really sophisticated methods, which go get a degree in math and go look at them, and you'll probably like them. The disadvantages of this whole system is basically, can you take what I've learned for this and apply it to another vertical, another thing? That's what it's trying to do. And the whole thing there is your algorithm any good? If it's not, that's where you run into problems. And since this whole entire approach is based around algorithms, if you don't have a good one or you don't have people maintaining it, you're not going to get good results. You can see the examples, like it's cool that I'm reading a news story about Donald Trump, and it can serve me other news stories about Donald Trump, but it'd be cooler to see videos. This says ads. I don't know who wants to see ads, but stuff like that. Other things that can be served up. There's also hybrid, so you take those two that we talked about. You can add some demographic stuff, which is pretty straightforward. Knowledge-based. Knowledge-based is kind of cool in a sense that it's a limited subset of data. Usually where, I kind of was thinking like, when you're checking into different health insurances and things like that, where you know what's best for your user, you know what the user should want or need in specific situations, whereas other times you don't. Which brings me to, I checked out this library called Good Enough Recommendations. There's a link to it up there. This is really simple to get up and running, so if you did have a website, you could add your products to this and have recommendation system built in really quickly. I kind of wish I knew that this was there for Stack Store, because we could have had cool recommendations and things like that. All you got to do is you create a new instance of the GER system, and then you make a namespace for your products. So this one, in these following examples, I'm going to use movies. And then you just add events to it. An event is used two ways. Basically, it compares two people and their history, and it's also used to provide recommendations based on that person's history. And in this library, luckily enough, time is a factor. So if it's been X number of 15 years since somebody likes something, it takes into account that they may not like it anymore. So pretty cool. And here's a real example. You can see we initialize the namespace movies. We add the 3 events. Bob likes X-Men, Bob likes Avengers, and Alice likes X-Men. And then you can see the recommendations for her. Since Bob liked X-Men and the Avengers, and Alice liked X-Men, we now serve her the Avengers as well. And then at the bottom, you see some neighborhood scoring and a confidence score. Basically, the more data you have there, the higher that number gets. Similarly, we check against people that liked X-Men, and we serve up the recommendation of the Avengers. So you like the Avengers. Conclusions, you got a lot of different approaches you could take. They're easy, they're hard, you can right down the middle. And pretty much all of them, you're going to get into algorithm work, and it's going to be kind of algorithm heavy. So if you like that kind of stuff, you'll probably like working on these. That's one thing I learned. And if you do want to use them on your site, Good Enough Recommendations, really easy to get up and running. So that was my presentation. Thanks.